Hello everyone, myself Dr. Khan, Associate Professor of Mathematics, Jagannath International Management School, Vasankund. I welcome you all in this video. In this video, we will discuss the Poisson distribution. As you are aware, we cover binomial distribution and questions in previous video. Now in this video we discussed the another distribution of probability known as Poisson distribution, and this distribution is very important for the point of view of examination also, right? So everybody have to pay attention towards the video. So Poisson distribution is a Poisson distribution is a particular limiting form limiting form of the binomial distribution when P or Q is very small and N is very large. When P or Q is very small and N is very large. The formula for Poisson distribution is Poisson distribution. Formula for Poisson distribution: PR is equal to m to the power r e to the power minus m divided by factorial r. M to the power r e to the power minus m divided by factorial r, where m is the mean of the distribution, where m is equal to mean of the distribution, okay, right? We can derive this with the help of binomial distribution, so we can prove this. So we have the proof of Poisson distribution. We know that in binomial distribution, we know that in binomial distribution PR is equal to NCR Q to the power n minus r PR. So P to the power r Q to the power n minus r. Since Q is equal to 1 minus P, Q is equal to 1 minus P, we can put here. So PR is equal to NCR 1 minus P to the power r into P to the power 1 minus P. Q is equal to 1 minus P here. तो 1 minus p to the power n minus r into p to the power r. Okay. So we can write mean m is equal to np. Since mean m is equal to the np, from here p is equal to m by n, implies that p is equal to m by n here. So we can write NCR 1 minus m by n to the power n minus r into m by n to the power r, where m is a constant. So now we can write n minus 1, n minus 2, so on n minus r minus 1 divided by factorial r for NCR. So m by n to the power r, m by n to the power r into 1 minus m by n, m by n to the power n minus r. In the next step we can write n by n, n by n, n by n minus 1 by n, 1 by n into n by n minus 2 by n, taking n is common, so on n by n minus r minus 1 by n divided by factorial r into 1 minus m by n to the power r, 1 minus m by n to the power r into m to the power r, m to the power r, 1 minus m by n, 1 minus m by n to the power n. On simplification it gives 1 into 1 minus 1 upon n, 1 minus 2 upon n, so on 1 minus r minus 1 upon n, m to the power r, 1 minus m by n to the power n whole divided by factorial r into 1 minus m by n to the power r, taking limits when n tends to infinity. Now taking limit and tending to infinity. So limit and tending to infinity 1 minus m by n to the power n is equal to limit n tending to infinity 1 minus m by n to the power minus n by m whole power minus m is equal to, we can write e to the power minus m. So PR is equal to, therefore PR is equal to m to the power r divided by factorial r e to the power minus m, or we can write PR is equal to e to the power minus m, m to the power r divided by factorial r, which is the required formula for Poisson distribution. So in this way you can derive the formula for Poisson distribution. Okay, now the mean of the Poisson distribution. Now the mean of the Poisson distribution. Mean of the Poisson distribution. Mean of the Poisson distribution. Okay, we know that PR is equal to, PR is equal to e to the power minus m to the power r divided by factorial r. Okay, so sigma FR is equal to 0 plus e to the power minus m, 0 plus e to the power minus m plus m e to the power minus m e to the power minus m into m plus m square e to the power minus m plus m cube e to the power minus m plus so on e to the power minus m into m to the power factorial r divided by r minus 1 factorial equal to e to the power minus m into m 1 plus m by factorial 1 by factorial 1 plus m square by factorial 2 plus m to the power 3 by factorial 3 plus so on. So mean is equal to sigma FR by sigma F, sigma FR by sigma F is equal to m by 1 is equal to m. So mean is equal to m. So mean of a Poisson distribution is equal to m. Similarly, the standard deviation of Poisson distribution. Similarly, the standard deviation of the Poisson distribution. Poisson distribution. Standard deviation of the Poisson distribution. Okay, so the standard deviation of the Poisson distribution is given by root m. Root m. We know that variance is equal to variance of Poisson distribution is equal to square root of standard deviation. Standard deviation. So we can prove the definition of we can prove the formula for standard deviation also and variance also, right? So mean of the Poisson distribution we prove here, and we also prove here the formula for the Poisson distribution. Okay, so this is all about the derivations of Poisson distribution and the proof of the mean and standard deviation of the Poisson distribution, right? I hope you understood. So if you have any doubt, any query, so comment me in the comment box of the video and we will discuss. So I hope you understood. So thank you all. We will come back with other videos of our syllabus. right? So thank you all.